Hello everyone, myself Kalichelvi, Assistant Professor, Department of Mechatronics Engineering, SNS College of Technology. Today we are going to see about the topic registers and shift registers, which is comes under the Unit 4 Design of Sequential Circuit and the subject of Design of Digital Circuits. Okay, so by end of this session, we will clearly understand what is a register and what is shift register, what are the types are there, and how it works. Okay, so this is the empathy of the register. So first we have to understand the need of the register. So data in computers is handling the binary values zeros and ones. So we need a temporary storage element to hold binary data. These elements must work with clock pulses. So this digital designers need to efficient to store and transfer and manipulate the data. So for storage we had already the flip-flops are there. So what is the need of that register means the group of flip-flops which is to store and transfer and manipulate the data is registers. So that's why we need registers for a digital logic. So this is the recap of previous session. This is the four flip-flops. So SR flip-flop, JK flip-flop, D flip-flop, and then T flip-flops. So flip-flop is a 1-bit memory cell which can be used for storing the digital data. Okay, so to increase the storage capacity in terms of number of bits, we have to use a group of flip-flops. Okay, so such that group of flip-flops is known as register. So the n-bit register will consist of n number of flip-flops and it is capable of storing n bit word. So the binary data in a register can be moved within a register from one flip-flop to another flip-flop. So this register that allows such data transfers are called shift registers. Okay, so there are four modes of operations for shift registers, that is SISO, SIPO, PISO and then PIPO. So which is nothing but serial in, serial out, serial in, parallel out, parallel in, serial out, and then parallel in, parallel out. Okay, these are the types. This is the shift register type, that is serial in, serial out, that is the data should be in serial and serial input, and then we have the serial output. SIPO means there is the input are in serial, but we have to take the output in a parallel manner. Parallel and parallel out means the inputs are also parallel and out we get the output also parallel. And then parallel and serial out means the inputs are in parallel but the output we taken as serial. Okay, so we'll see one by one. So first image is a schematic diagram is mentioned that SISO, that is serial in, serial out. Let all the flip-flop be initially in the reset condition, that is Q3 equal to Q2 is equal to Q1 is equal to Q0, all is equal to 0. If an entry of 4-bit binary number that is 1111 is made into a register, this number should be applied to D input with the LSB bit applied first. The D input of flip-flop 3, that is D3, is connected to serial data input D in. Okay, the output of flip-flop 3, that is Q3, is connected to the input of the next flip-flop, that is D2, and so on. So this is the block diagram. So this serial and serial out is in the shift left and also having the shift right registers. Okay, next one is serial in, parallel out. So in such type of operation, the data is entered serially and taken out in parallel fashion. Okay, so data is loaded bit by bit. The output are disabled as long as the data is loading. So as soon as the data loading gets completed, all the flip-flops contain their required data, the outputs are enabled. So that all the loaded data is made available over all the output lines at the same time. Okay, so 4 clock cycles are required to load a 4-bit word. So hence the speed of operation of serial in parallel out mode is same as that of serial in serial out mode. Okay, so this is the block diagram of that SIPO. And then PISO, that is it has the parallel inputs and then serial outputs. Okay, so data bits are entered in parallel fashion. The circuit shown below is a 4-bit parallel input, serial output register. So output of previous flip-flop is connected to the input of the next one via combinational circuit. So the binary input word B0, B1, B2, B3 is applied through the same combinational circuits. There are two modes in which this circuit can work, namely shift mode or load mode. Okay, so and then fourth type is parallel in parallel out. In this mode, the 4-bit binary input, that is B0, B1, B2, B3 is applied to the data inputs D0, D1, D2, D3 respectively of the 4 flip-flops. So as soon as their negative clock edge is applied, the input binary bits will be loaded into the flip-flops simultaneously. The loaded bits will appear simultaneously to the output side. Only clock pulse is essential to load all the bits. Okay, so this is about parallel in parallel out. So also we have one more type, that is universal shift register. The shift register which can shift the data in only one direction is called unidirectional shift register. It allows the both the direction is called bidirectional shift register. Applying the same logic, a shift register which can shift the data in both direction as well as load it parallelly is known as universal shift register. Okay, so it can perform parallel loading, left shifting and right shifting. So that is about universal shift register. So this is the mind map of register. So here mind map is uh, given for the summarization purpose, that is what is definition and basic concepts. Here I am giving the types of register and modes of operation. So this is about the shift register and then register. Okay, so these are all the reference we have referred for this presentation. Hope you all understand this register and shift registers. Okay, thank you.